there are two thrust levers installed. They are manually positioned by the pilot and are never automatically positioned. Forward and aft movement of the levers is available over a sector with detents and stops. The toga stop is used for setting maximum takeoff power or for setting go-around power. The flex MCT detent is used for setting reduced takeoff power or for setting maximum continuous thrust. The climb detent is selected after takeoff for normal operations. This action sets thrust for climb. The thrust levers remain in this detent until landing, and auto thrust sets power as required. During landing, the thrust levers are manually retarded to and stopped by the idle stop. The idle stop is an intermediate stop that may be overridden on the ground by lifting the reverse levers and then retarding the thrust levers into the reverse range. Reverse thrust may be varied between idle at the reverse idle detent and maximum at the maximum reverse stop. After reversing, the idle stop is reset when the thrust levers are advanced past the idle stop, and after resetting the stop, the thrust levers are again retarded to the idle stop for taxi. The position of the thrust lever is transmitted to the associated FADEC, which then computes and displays on the EWD the E per thrust rating limit for the selected thrust lever angle, TLA. If a thrust lever is set in a detent or stop, the FADEC computes power for the selected detent or stop. If a thrust lever is set between two detents, or a detent and a stop, the FADEC computes power for the next higher detent or stop. Thrust control operates in the manual mode or the auto thrust ATHR mode. The manual mode provides conventional throttle operation, with the FADEC setting power according to the thrust lever angle selected by the pilot. Therefore, in manual, the pilot controls thrust by moving the levers between the idle and toga stops. Read the pop-up details about the manual mode operating conditions. In the manual mode, the flex MCT detent requires an explanation. With the aircraft on the ground, this detent selects flex takeoff thrust if the crew has selected a flex takeoff temperature that is higher than the current total air temperature. If the crew has not selected a higher temperature for flex, this detent will set maximum continuous thrust on the ground. Note: a change of the flex temperature during the takeoff has no effect on the thrust. If the flex setting was used for takeoff, the pilot can select MCT thrust by either moving the thrust lever to the toga stop or climb detent and then back to the flex MCT detent. After this has been done, flex power cannot be selected until the aircraft is again on the ground. Note: the thrust lever must be fully moved to another detent stop to effect this change. If the lever is not fully positioned to another detent stop, the flex power will continue to operate. Regardless of the auto thrust mode, the pilot can always set maximum takeoff thrust by advancing the thrust levers all the way forward to the toga stop. Likewise, the pilot can select idle by retarding the thrust levers to the idle stop. Note: if the thrust levers are moved to the idle stop, auto thrust and alpha floor will disarm and deactivate. Additional takeoff or go-around thrust can be obtained, up to 6.5% increase, by use of the thrust bump feature. This increased thrust can be obtained by pressing the thrust bump push button switch on either thrust lever when the thrust levers are forward of the flex MCT position during takeoff or go-around. Whenever thrust bump is engaged, a green letter B is displayed beside the EPR gauge of each operating engine. Thrust bump is cancelled by pressing either thrust bump push button or when the thrust levers are retarded to flex maximum continuous thrust or climb. The auto thrust mode normally engages when you move the thrust levers to the climb detent after takeoff. The levers remain in this position until landing, and the FMGC controls the thrust. The auto thrust mode sets the power by signals from the FMGC, but the thrust is limited to the value corresponding to the thrust lever angle, TLA position, unless the alpha floor mode is activated. The FADEC monitors the positions of the thrust levers and triggers appropriate indications in the first column, auto thrust of the FMA. The last few frames will describe some of these indications. After takeoff with both engines running, when the aircraft reaches thrust reduction altitude, the FMA shows a flashing white annunciation of lever climb on the third line. After takeoff with an engine failure, when the speed reaches the green dot, the flight mode annunciator shows a flashing white annunciation of lever MCT on the third line. During normal operations, an amber display of lever asymmetry appears on the third line if auto thrust is active with both engines running, and one thrust lever is set out of the climb detent. Now let's answer some questions.